I apologize for the title, it lacks imagination, but hopefully I will be able to prove by the end of my talk that Dagger really is the best. So a little bit about me. I'm Mark. I work at Cisco right now as a technical lead slash SRE. And I've been writing Go for a while now. So naturally, I use the Go SDK for Dagger. I really like OSS, so you may have seen me contributing to a bunch of Go software on GitHub, and I'm really obsessed with developer experience. So this is one of the reasons why I really like Dagger, but we'll get to that in a moment. So really, I'm supposed to talk about this tweet. So a couple of weeks ago, I was debugging GitHub Actions pipeline. And it took me a while to fix the problem. And then I was curious how much time it would have taken if I was just using Dagger. Basically, I recreated the same environment with Dagger, and I measured the length of the feedback loop, basically using GitHub Actions and then using Dagger. And obviously, using Dagger was way much faster because I was able to run the whole pipeline locally, and I didn't have to commit and push and wait for GitHub Actions to pick up the job and for it to finish and fail. So the feedback loop was Dagger was way faster. But as I was, and then Birender reached out to me whether I wanted to talk about this, and I'm really happy to be here. And as I was preparing for this session, I realized there is kind of a deeper background here, or a deeper story that we could talk about. I promise it may seem that I'm stepping back too much, but I promise it will connect to this tweet at the end. So I'm pretty sure everyone had this kind of problem before, either from an operations or from a development perspective, that something worked on a developer's machine and then it broke in production. And this is kind of a joke, but this really created a silo between operations and development for a long period of time. But fortunately, as things progressed and technology evolved, I think we are at a really great place right now, plot twist containers, solving this problem. So we had this meme for a while, but for some reason we didn't really have this kind of meme. I mean, no one was really laughing at the fellow developer when something break on their machine, because obviously it was a different environment. They had different versions of packages, and when the development workflow breaks on another developer's machine, that's a pain, and that's something we have to solve. And for this problem, we also invented a bunch of different solutions that I will be talking about in a minute. But this is really a pain, and we don't really see this meme. We see the other one a lot. We don't really see this meme. So this is a pain as well that we had for a while now. And the last problem in this space is obviously with CI. So this is also something that we are not laughing about, because this is not someone else's problem. Just like having to solve problems with the development environment not being portable enough, developers have to solve problems with CI as well. When something works on the developer machine, tests are passing, everything is great, and then it breaks in the CI because the development or the test environment is not portable or not the same in those two different environments. So let's briefly take a look at how this evolved in these three particular environments. And I will be talking about these as three separate environments. So if you think about like production environments or deployment pipelines, there are a bunch of different solutions. I just listed a couple here, but we basically went from copying artifacts from a developer machine to production. That was the old ages. to containers these days. And containers work really great because they provide a consistent environment from development to production. And we rarely see any problems anymore where something works on the developer's machine and then it breaks in production because the environments are the same. And obviously we had different solutions in between. So at times, and I'm pretty sure some of you at least had to do this in the past, when you had to build entire virtual machine images and you had to deploy those to production, immutable infrastructure. And that worked, that solved the problem, but it was still a pain. So this is kind of the production environment. And then the development environment also had a bunch of different solutions for the portability and the reproducibility problem. So we went from shell scripts that were not reproducible, that may have broken on another developer's machine, to make files. And then we had this kind of whole virtual machine thing again with Vagrant. And then we moved to these so-called modern build systems like Bazel or Please or Buck or whatever else. I'm pretty sure some of you use those. I use Please, and I really like that. When I wanted to build something, I had to type please build and then please test and stuff like that. That was really great. And in the end, again, today we have pretty great solutions for developer environments. We use containers a lot, but with the introduction of Go and Rust, finally we can, and the fact that we can run Linux on Windows as well. So technology evolved a lot. And finally, we are at a place where we can go back to using native tooling if we want to. We can use things like Nix. That's really great. I really like using Nix for moving one environment to the other. We obviously have containers as well, but to be honest, in a lot of different use cases, using containers is just not that great experience. I mean, if you want to run tests in a reproducible environment, if you start things like typing, I don't know, Docker run, and then you have to think about caching, so have to pass a lot of parameters to Docker run. You have to mount the right directories to the container. So it's not that great experience to use containers directly. So we will obviously have some sort of tooling for that in the development environment as well. And I just want to call out in this case as well, and in the previous one, is that we went from a non-isolated environment like shell script to a completely isolated environment like Vagrant, and then back to some sort of balance between the two. Like Vagrant had the same problem that then building and deploying VM images to production, running those Vagrant virtual machines, really, they took a lot of resources from the computer. It took a lot of time to rebuild those images. So that wasn't great. And containers are much better. And really what's common in these two environments? One, kind of talked about that, the level of isolation that you get. It's not a completely isolated environment. It's not a virtual machine that you deploy. It's not a virtual machine that you work in on your development machine, but maybe containers. That's like a good middle ground between a not isolated and a completely isolated virtual machine. It's a good balance. And the other thing that you have is some sort of abstraction on top of containers. Like if you deploy to a production environment, you have Kubernetes or something else. When you work with containers in a development environment, you will have some, I don't know, shell scripts or a makefile or some task runner that hides the fact that you are actually using containers, because as I mentioned, using containers is not really great for these development tasks, or at least not all the time. So for CI, we don't really have this kind of progression. I mean, CI obviously evolved as well from, I don't know, Jenkins or Hudson to GitHub Actions these days, but we don't really have this kind of clear progression from a non-isolated environment to something that works great for developers. Obviously, with GitHub Actions and GitLab, you can have your own runners, and you can have your own runners on your computer if you want to, but that's not a great user experience. So we don't really have this kind of progression as in the other two cases. And one of the solutions that we did as developers in the last couple of years is that we try to use or try to build a development environment that we can just run the same way in CI. And I think that kind of failed. So that was an environment that I had to debug for an hour in GitHub Actions that was running perfectly on my machine. I was using the same commands, the same tools, and for some reason it failed on Linux in GitHub Actions. And the reason for that was it wasn't running in a container, so it wasn't a really isolated environment, unlike in Dagger, for example. So you'll probably see where I'm going with this. But since I was using the exact same tools that I wanted to use on my computer, it was failing in the CI, and I kind of got to this realization, and this is my opinion. So you may disagree with this, but you don't necessarily have to aim for having the same environment in dev and CI. You just need something that's reproducible in CI and on your machine as well. And obviously in a development environment, you will have a bunch of other tools as well that you don't need in CI. So you have a little extra like leeway in your development environment if you don't tie it to CI as well. So, and where does Dagger come into this picture? So Dagger uses containers. So it provides you a good level of isolation compared to like using a make file that downloads the dependencies that you need for the building a project, for example. So it provides a better level of isolation than that. And it also has a great abstraction on top of containers. As I mentioned, in development environments, we have this problem that running containers manually is not really great. I mean, you certainly have some shell script or make file on top of that. You don't want to use Docker run all the time because you have a bunch of options that you have to pass to that command. So Dagger has a great abstraction on top of containers. And well, that's why I think Dagger is the best. And how does that connect to this whole, I promise that it would connect back to this whole debugging experience here. So since I was using Dagger and I was using containers, I was pretty sure that if I ran the same build on GitHub Actions, I would get the same result because I had that right level of isolation that I would be able to reproduce the same environment in GitHub Actions, and I would be able to, I would be fairly sure that if I ran the same thing in GitHub Actions and on my computer, it would give me the same result. And on top of that, since I was able to run this whole thing on my computer as well, because Dagger gave me that level of abstraction as well, that I didn't have to manually run containers, or I didn't have to use GitHub Actions, write that YAML file and run containers in there. So I could easily run this whole build on my computer as well. I was able to fix the problem fairly easily. And then I was able to just push the code once to GitHub, and obviously the build was green. So I didn't have to go through that whole commit, push, fix cycle because I was able to run this whole thing on my computer thanks to Dagger's great Go SDK, which is the abstraction in this case. So that's really the gist of it, and I can actually show you the code itself. So let's see. Let's zoom in a bit. So the project in question was actually Viper. Viper is a fairly popular project in the Go ecosystem. And let's see. By the way, I was actually able to, so I was a bit concerned about using Dagger in Viper because it adds that dependencies to the Go module, but I was able to put this whole thing in a submodule using Mage, so that I don't have to include Dagger itself in the main library, and then the consumers of Viper won't complain about the additional dependencies, and it actually works great. So the primary code is basically in two files. I use Mage. I kind of didn't like Mage before because it requires you to compile a binary and run it, but since I'm using the Go SDK, works fairly great for this particular use case, so it's okay. So it's probably familiar to you if you use the Go SDK. Basically, you just start and connect to Dagger. The path in this case will be the current directory if we want to run it from the root, but if not, then we have to change it back to, so it goes back to, so again, this code is in a CI subdirectory. It's a submodule. And then the whole test functionality is moved out to a different function. I actually want to make this act like a pipeline. So I want to pass through a build context, a series of steps, similarly to how, I don't know, I think in some of the previous community calls, I saw someone doing something similar, that they passed through a context, a series of steps, similarly to how a pipeline works. And this is something I'd like to build here eventually. So the whole test code is moved out to a different function. Couple input parameters is the work date and whether I want to run the race detector. And basically it returns a container with those parameters. And then I can just show the output. If I go here, I can just, let's see, mine is the CI and then run test. And it's not really well optimized because right now, every time I change something, it's going to download the dependencies again. But that doesn't really affect the measurement because I don't have caching on GitHub Actions either. But most of that 40 seconds actually is downloading dependencies. So if I tweak the pipeline a bit, then this could be much faster because I didn't have to re-download the dependencies over and over again. So if I don't know, change something, then it will download dependencies again. And if I time this, basically, the only thing I need to time to measure the feedback loop is the time it takes to run the pipeline itself. And it's fairly quick for Dagger for this project. For GitHub Actions, obviously, you have to commit and push and wait for GitHub Actions. And that takes a lot more time. But with Dagger, it's much faster. So yeah, it's 20 seconds in this case. So that's what I had for today. Happy to answer any questions. And yeah.
Thanks, Mark. This is great to see. And yeah, thank you for all the context and the history behind how you got here. And then also the demo to show it off too.
Absolutely.
If anyone has any questions, as a reminder, use the chat feature. Thank you to everyone who had one. Oh, Tini, you raised your hand. Did you have a question?
No, I misclicked.
Oh,
for
sorry.
now.
Oh, no worries. Everyone's figuring out.
Well, actually, I have a question. Why do you download every time? Why is it not cached on the initial step?
The reason for that is because the only command I run here is the where is it? Is the go test command. So there is no. So whenever I change something, I guess it's here because of the order how I mount and run things. So whenever I mount the code, it's going to be changed. And I mount the code with the Go module files together. So that I don't have a separate Go mod download step that would actually cache the dependencies. So I could do that. I just didn't.
Yeah, there is you can use a mounted cache with mounted cache, and then it would like download that in a cache, and normally it should.
Oh yeah, cool. That would probably be better actually. So otherwise, I would
it's
have
better
to,
than the copying the Go mod and then doing the gem.
Yeah, that's
cool.
a better solution. Yeah, cool. Thanks for the tip.